So, hi, my name is Evie Williams.
And I'm Lily Dimitrova.
And we hope you enjoy our project. So, what problem is it that we're trying to solve here? Well, lameness is a term that we use in the horse world to refer to an abnormality of gait caused by any sort of injury. And it's a problem that many horses will experience at some point in their lives. 90% of these cases are related to equine orthopedics, so originating in the foot, or most specifically the lower leg of the animal. Now, we're focused on the sport of show jumping, and the biggest cause of lameness that will affect show jumping horses directly is overuse of the superficial digital flexor tendon, or the SFT, which is the tendon that runs down the back of the horse's leg. Now, as you can see in the picture, that horse is landing the jump, and the rounded part of the horse's leg towards the bottom, otherwise known as the fetlock joint, is being pushed down to absorb the weight and the force of that jump. And that is what's stretching that superficial flexor tendon and can cause a lot of injury.
Also, this isn't normally very easily detected, so having a device would really help.
So what's our solution? So we've created smart tendon boots. These will act as a guideline for riders to help them understand how much force their horses are actually experiencing when jumping. The way they work is that they have technology integrated within them that's able to measure the downwards acceleration and feed this back to an app, which will have our pre-estimated or predetermined maximum accelerations, otherwise known as benchmark. And if the current acceleration that the horse is experiencing exceeds this, then the rider will be alerted to stop. This is useful because it will help prevent the rider from overworking their horses on tendons that have experienced too much force or too much stress, and allow a horse a proper period of rest. Another thing that amplifies this problem is the fact that a lot of riders do not realize when their horses go lame or are injured, because injury can be very, very small, but can build up over a certain period of time. And we can see that in the statistic below, where 60 sport and sound riding horses underwent scientific analysis, and it was found that actually 73 had gone lame, meaning that riders just cannot pick this up by eye.
So the way that this will work, it will use a MEMS accelerometer, which will constantly measure the acceleration it experiences. There will also be a microcontroller, which will be collecting the accelerometry data every millisecond, and it will find the moving average over 0.1 seconds. However, this could also be over 0.2 seconds. This is just to save storage and have a better understanding of how much force your horse is experiencing. The current value of the moving average is then sent to the HC05 Bluetooth module every second. It's then compared with the most recent maximum acceleration. And if it is larger, it's just immediately sent to the Bluetooth module so that you don't have to wait for this moving average. The Bluetooth module is also paired with a mobile app, which collects the data from the microcontroller and will alert the rider if the maximum acceleration has exceeded the predetermined benchmark value. And over here we have a schematic diagram of the prototype in partnership with De Montfort University. And we also have a video demonstration for you, so please let me know if you can't see or hear it. Oops.
Of the prototype. Hello everyone, welcome to the video demonstration of the prototype. This right here is the Arduino. This over here is the hardware. This over here is the HC05 Bluetooth module. So we're going to open the app now. At the top right there's a button that says connect. Connect to the Bluetooth module. Right, and let's say the horse would be jumping at 1.1 meters. Into 1.1. The value on the right is the calculated acceleration for which the horse can take at jumping at this height. And the 9.70 is the acceleration on Earth. And the app is ready to record movement and acceleration. So if I take this and move it, the value will change. There we go. If I go a bit more. Now, as you can see, the light bulb has gone magenta, which means that the rider has been alerted that the horse has taken too much force. Thank you.
So this is obviously a prototype and simply the foundations and proof of concept. However, if we were to make a finished product, the app would work in terms of force instead of acceleration, using the simple equation force equals mass times acceleration. This is because the mass of the horse, mass of rider and tack, which is the stuff that's on the horse, may vary, and obviously the force will be greater if there's more mass. Prior to riding, the app will ask the rider to insert the following data and different factors that may affect the amount of force the horse experiences.
Adding on to what Lily has said, what you've just seen in the video is simply a prototype and the foundations or the bare bone of what we're trying to build. And so continuing to build the app, we would aspire to go for something like this. As you can see, the rider will be asked to insert their personal details, as well as the following information for data collection, processing, tracking, and further research purposes.
So the calculations used in this are from a paper, and the details are at the bottom. They used 4 different jumping heights from 1.1 meters to 1.4 meters. And we calculated and estimated more maximum values for these jumping heights using a curve of best fit. Here we have the table that we're talking about, and we're looking at the maximal vertical force, which is in newtons per kilograms, but that just equates to acceleration, so that's not a problem. And we did actually do some coding as well. On the left, we have the Arduino coding, which is written in C. And for the accelerometer part, this is how it deals with the accelerometry data, simply using 3D Pythagoras. We also have the rolling average, which can be changed, and we have the Bluetooth module, which is connected to the app using the command serial print. And on the right, we have the Android app, which is written in Java. We have the estimation equation over here, which is used to make these predetermined values. Now, how we made these predetermined values were from 2 different types of formulas. We interpolated and extrapolated the data to figure out the values in between it and predict the rest of the data. On column D, we have the line of best fit, and they are linear approximations. And on column E, we have the quadratic approximations. From 0.5 to 1.25, we took the linear approximations. And from 1.3 to 2, we took the quadratic ones to make a more smoother line, not as jagged, and it makes sense. So we ended up with column C, which was the curve of best fit, and that is how the graph looks like.
Okay, so just to summarize, this is simply just a summary slide to show you the events and the processes of using the product and the app. We're not going to dwell on this side, but the most important thing to take away from this is the fact that the benchmark force is predetermined and simply an estimation based on the data that you've already seen. That's because we simply don't have access, or there hasn't been enough studies done regarding horses and forces in show jumping, or there hasn't been any studies collecting accelerometry data that we could use.
The study that we did use was quite recent.
Okay, so how is this innovative and how is our product actually going to help? Well, there are a number of reasons, as you can see. Firstly, wearable technology just hasn't really made it in the equine world. Currently, there are companies and businesses trying to build it up and trying to develop it, but again, it just isn't there. And we see this as a problem because horses are just as much athletes as humans, and we think technology like this will really, really help horses and benefit a lot of equestrian athletes. Again, this is going to provide a really affordable and easily available solution to one of the biggest problems in the equestrian industry, because the components, the materials, everything that actually goes into the whole product, the actual boots, is incredibly cheap and very low cost. This can also help many equestrian governing bodies to collect data over a certain period of time and putting more competition restrictions and rules to prevent overuse. What this means is currently a very, very small pony, for example, could jump 160 or could be entered into that sort of course and jump that height. And obviously that is not good for its tendons because that horse is not built to jump that height. However, seeing this data presented to governing bodies, they'll be able to see facts rather than opinions and put in these restrictions to benefit the welfare of these animals. Again, researchers can also use this to gain a better understanding of the specific factors that contribute to injury or optimum force, i.e. if a specific breed jumping a specific height injures themselves, you'd be able to look at everything that contributed to that horse injuring itself and then further put in restrictions and rules. And this can also simply be used to better our actual product. As we've said, this isn't as accurate as we'd like it to be. Broadly speaking, it is where we'd want it to be, but it can better as time goes on and more studies are done. We did speak to a professor from University of Liverpool who was previously a vet for 5 years, who said, quote, "It would be very useful and would definitely have its place in this industry," which again just backs up the fact that this isn't a thing, this isn't there, and it definitely would
change the game.
Yeah.
Over here we have collaborations involving University of Cambridge, De Montfort University, University of Liverpool, and Royal Veterinary College.
Thank you.
Thank you for listening.
Thank you very much for your presentation. I have a question from the jury member.
Hello.
Hello. Hi.
Yes.
Evie and Lily, I have a question.
Okay.
Yeah.
What is the maximum possible measurement error in your device?
Well, as we said, with these measurements, they are an estimation from what we already know. However, this device could also be used for research to then overcome this problem, since there are not many studies done into this. However, our product would help with that issue.
Thank you very much.
Thank you.
Thank you.
Okay, I also have a question. Thank you for presentation. Could you please describe users' experience? So how these devices should be used? I mean, you have to attach all these devices to all 4 legs, and horse should use it all the time, or how you collect information, how you then make decisions based on this information, all this.
Okay, so when we're talking about tendon boots are used all throughout the equestrian industry, if you like. It's simply just a piece of plastic that will wrap around the front 2 legs of the animal, which are the 2 legs that we're focused on.
Since they do absorb a lot of the force when they do land. And
so the technology will actually be integrated into these boots, and so can just be simply added, attached to the horse in a normal and very easy way. Prior to actually riding the horse, as you've seen in the app design, the rider will be asked to insert everything regarding the weight of the horse, weight of the rider tack, breed, height, and height of the fence. Which most riders already know. That's and it's really easy to obtain this. If a rider doesn't know the weight of their horse, you can simply buy a weight tape and calculate it yourself. So it's very, very simple. Then they simply just ride their horse over the course, and the boot will be able to pick up the accelerometry data, compare this to what we've already pre-estimated would be bad for that specific horse, and then compare the 2. And if it is bad, if it is negative and exceeding that benchmark that we have,
the rider would be notified through, let's say, a smart app, through a notification. I hope that answers your question.
Yeah, thank you.
Thank you.
Did you make a patent search in this field?
Could you please repeat that?
Did you make a patent search in this field? Search in patent databases.
We did get previously conducted studies. We got one which was done quite recently in 2020. However, not many studies have been done, which is why we did have to estimate a few values. However, this could also be used to find out more about this issue of lameness, and it can be used for research purposes as well. And then this research could then better the understanding of riders, better the technology that could go into horses, better the technology that can go into the industry.
Additionally, like Lily said, there hasn't been any grand scale study regarding accelerometry data, and if there is, it isn't readily available. We've read loads and loads of papers, and a lot of them have concluded that there's very little research into this field, and so we simply see our boot as kind of like the first step in actually overcoming that and bettering our understanding of forces, accelerometry data, and this whole sort of scientific approach to show jumping.
So you see this project as scientific project, not as commercial in the future.
It can be used as both, because there has been, whilst there hasn't been a lot, there still has been some. But once we do get the necessary data, this can be introduced into the market and used as a commercial product, since that we would have accelerometry data for different factors such as breed. And
this product is both commercial and both scientific, because it's enabling riders to, if their horses have injured themselves and are continuing to work that tendon, then they're going to increase the chance of going lame, and then that rider can no longer compete that horse. That's the problem. So we've created this product that's capable of stopping the rider from actually doing that, and allowing a horse a proper amount of rest time, which they don't normally get because they're traveling everywhere, competing everywhere, and jumping all the time. And so even if it's just 2 minutes just to let the tendon rest before starting again, or even if it's just getting off the horse completely, that's what we're preventing. And as well as this, because of the database, because of the tracking and everything, we'd be able to better not only the product, but our understanding.
Thank you.
thank you.
I have a small question. Do you practice horse riding yourself?
I do, yes.
Oh, yes. Okay. It's very interesting. Thank you.
Thank you.
Yeah. Small question for the ladies. Thank you very much for your very interesting presentation.
Thank you for listening.
Opens up a wide scope of questions, and the approach of monitoring these problematic areas, not only in animals but in people too, is definitely a future of this biotechnology cross field. With your particular device, have you thought about possible scenarios of it failing completely, where the injury will actually occur and the device will not be able to detect that the injury has happened? Like, what would be the conditions that could have be the case?
So now, in most of the limbs, in 90% of cases, it's in the lower legs, and it's the superficial digital flex tendon, which is where the boots will be placed. The other 10% are in other limbs. However, this is quite rare in this case. I suppose it won't be able to pick up this, or the battery life may be a problem. However, we have discovered the 1.2 amp 9 volt lithium ion batteries that would have 60 hours continuous use, which is quite a long time. We have quite low power need components, so I don't think that that'll be a massive problem. But yeah,
so I think what you're trying to ask is there anything that would go really, really badly and the product wouldn't be able to pick it up? Okay, so simply, horses in show jumping, they're over time, they've evolved to have tendons that are really, really stretchy. And so they can actually deal with quite a lot of force and shock absorption. The problem is, you could think about it in terms of sort of football and rugby. Every time footballers hit the ball, or every time they're tackled by a rugby player, that's doing some sort of damage. And this is exactly the same principle with horses. Every time they're jumping massive heights and traveling across the world, it is damaging their tendon in some way. And so what we're trying to do is reduce that. So the actual accelerometry data is going to be pretty consistent that we're picking up. And so we do believe that the boot wouldn't have a problem with doing that. There wouldn't be anything that would go.
Yeah. Then again, this is like the first step. This is like raising awareness about this as well, because it's such a big problem, but very little solutions for this.
Yeah, I agree. For raising the awareness, definitely is the way forward. But with the device itself, perhaps as future work can look at all possible scenarios, of course, going around the court and maybe kind of hitting something, it turning.
Yeah, we have actually thought of that. So in terms of durability, we're aware that the biggest limiting factor to this project is if the horse was to knock a fence down or was to hit the tendon and the technology just completely goes. Therefore, it's just, it has no use. In this case, we obviously want to make it as durable as possible, and we have to look at the certain materials that we would integrate into it. And companies who build tendon boots nowadays, we're beginning to see that sort of innovation. We're beginning to use carbon fiber, Kevlar fiber, things like that. And we definitely use these sorts of materials. Kevlar, which is, you know, stronger than steel, really cheap and actually very lightweight, would definitely be integrated to help protect both the tendons and the technology in the boot.